Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Mechanical Properties of Fluids. Okay, so let's go through the question and then understand all these basics. So question is, an air bubble of radius 0.1 centimeter lies at a depth of 20 centimeter below the free surface of a liquid of a density 1000 kilogram per meter cube. Now, if the pressure inside the bubble is 2100 Newton per meter square greater than the atmospheric pressure, then the surface tension of the liquid is how much here in terms of SI unit. Okay, so here what we'll do here, first we'll collect the data and all. So you can see very well there is the one bubble is there. No, I have just shown here with the green color and it is at some depth. Okay, so let's take here, this depth is h. Okay, and after that let's take for example the radius of this bubble. Now this radius how much is given here, r, and let's take the density of this liquid is the rho. Okay, so all this data we are going to write down one by one. So let's see here please, the radius how much given here, 0.1 centimeter. Okay, 0.1 centimeter. After that depth how much given here, depth is given here 20 centimeter, that means h is given here 20 centimeter. Okay, and the density of the liquid how much given here, 1000 kilogram per meter cube, that means definitely it is water or similar to the water, something else. After that, see, if the pressure inside the bubble is 2100 Newton per meter square greater than the atmospheric pressure, that means see here, let's take if the pressure inside this bubble is P in, what I'm telling, P in. So this inside pressure is given here, atmospheric pressure plus how much, 2100 more than, and anyhow SI unit Newton per meter square. Then what they are asking, the surface tension of the liquid they are asking. That means here we have to calculate here the surface tension, this one. So this is the question scenario, is it? So students, here we have to use here the multiple concepts here. Multiple concepts, actually there are two concepts we have to use. First concept we are going to use that here, whenever any kind of a bubble is there, is it? Let's take here inside pressure is P in and outside pressure is P naught. Then the formula is used to be this one here. P in is equal to P naught plus 2T by R. 2T by R, remember that here, if in case there is one free surface means here you can see here what is there, air is inside the liquid, that means the free surface is inner one. Similarly, if in case let's take for example liquid drop is there, in case of liquid drop inside water is there, but outside what is there, air is there. There are also one free surface. So we can tell here, we can tell air bubble inside the water or liquid drop inside the air. In both this situation, we can use this formula. One more situation comes if in case there is the one soap bubble. So in case of soap bubble, there used to be the two surfaces. Outside also air, inside also air. So in that situation, we will use 4T by R. But according to our situation, we have to use this P in equal to P naught plus 2T by R. Okay, this is one concept. After that, remember that one more concept is there. If in case here, now at the surface which pressure is there, atmospheric pressure is there, and how much depth is there, h. So at a depth, remember that here the pressure. Now let's take here pressure how much is there, let's take for example here, just here the pressure how much here, P. So we can write here this P equal to PA plus rho GH. This is called a pressure variation with depth. Okay, so if the here pressure is P, we can write P equal to PA plus rho GH, and this is. So students, these two concepts we have to remember that to solve this question. Okay, now after that, if we write here the equation, if we write here the equation according to our situation. So students, here we can write here, see, this P in minus just outside the what to tell, this air bubble, what is the pressure I have taken, P. So I can write here P in minus P. Okay, P in minus P, or we can write here, see here, P in equal to P plus 2T by R. Again, see, I am writing from here. This is P in just outside P. That means what can I write here? P in equal to P plus 2T by R. And even if you want to make it here, for example, if you want to make here the pressure P naught, then okay, this also you can write here the P naught, and this also you can make here P naught, not a problem is there. Okay, so this is our the main equation. P in equal to P naught plus 2T by R. What is the value of the P naught, students? This P naught is given by this one, PA plus rho GH. What is given here? PA plus rho GH. So I will go to the next page here and let me write here, please. See, as again I'm telling that here, see, this P in is equal to P naught plus 2T by R for one free surface. Now, anyhow, then after that, this inside pressure is how much given here? Inside pressure is this PA plus 2100. Now, I will write here. This inside pressure, how much here? PA plus 2100. This one we have got here. After that, this P naught, you know very well, here I have taken P naught. How much depth? H depth. That means this P naught I can write here PA plus rho GH. Now here PA, depth is H. That means what can I write here? This will become here PA plus rho GH plus 2T by R. I hope so this is very, very clear to you, because this is the main equation. This inner pressure inside the what to tell air bubble, this one here, PA plus 2100 according to the question. And this one here, now at a depth of H, the pressure what is given here, PA plus rho GH. Is it? I hope so very clear. Now after that, what will happen that here, students? See, so both the sides, this PA and this PA will cancel. Now, so we can write here, see, this 2100 is equal to rho GH plus 2T by R here. Is it? Now after that, if I write here the 2T by R, so this 2T by R will become here what? 2100 minus rho GH. Is it? Rho GH. Next one, see. Next one. Now only calculation left, see. 2T by R is equal to, see here, the 2100 minus rho, how much given here? The 1000 into G value, nothing is mentioned. 10 and H, how much given here? Again, go to the back one here. H, how much given? 20 centimeter. 20 centimeter. Convert into the meter, so it will become here the 20 into 10 to the power minus 2 meter. Okay. So after that, if we are simplifying this here, this 2T by R is equal to 2100 minus. So here we can write here, see, 2 into 10 to the power, how much here? 315. So 2 into 10 power 5 into 10 power minus 2. Is it? So after that, if we'll go here the further, see, further we are going here, see. So we can write here this 2T by R is equal to, this is 2100, no? 2100 minus. This one will come how much here? 10 power 5 and 10 power minus 2 means 10 power 3. And here this 2 is there. So we can write here, this is the 2000. So when we are simplifying this, it will come here, this 2T by R is equal to 100. Is it? So from here, we can write here, this T equal to 100 R by 2, or we can write here the 50 R. Now see here, we have got it very easily. How much? T equal to 50 R. Now, the value of R how much given? 0.1 centimeter. Okay. But here in the question, they are asking in terms of the SI unit. So 0.1 centimeter, how much we can write here? 0.1 into 10 power minus 2 meter, or we can write here 10 to the power minus 3 meter is there. Now, this value I will put here. So what this will become here? See, 50 into 10 to the power minus 3 meter. So 50 into 10 power minus 3, what this will come here? When you will simplify this, even we can write here, see, 50 into 1 by 1000 even, meter. So students, after that, if you will simplify this, it will come 0.05 meter. This, the surface tension value is coming how much? 0.05 meter? No, mistake happened here. SI unit of the surface tension, how much? Newton per meter. Okay, so you can see very well, students, the surface tension is coming how much here? 0.05 Newton per meter. Okay, so if we'll check here the option here, any option 0.05, yes, you can see here. Option D is matching. Okay, so students, here in this question, we have learned the two concepts. First concept, we have learned about the bubbles and all that. Because of their spherical nature, the pressure will be inside will be more. How much? Inside pressure P naught plus 2T R. For one free surface, 2T by R. For two free surfaces, 4T by R when soap bubble in a air. And after that, another concept is that when we are going inside the liquid, so at a depth of H, pressure will be more. How much pressure will be there? This P naught equal to PA plus rho GH. Is it? So I hope so, students, this concept you have understood very well. Thank you so much.